Good afternoon, class. Today we are going to see another three operators in C++ language. Before that, in the previous classes, we have seen what was an arithmetic operator and what was a relational operator. Just a brief glance we will have. Arithmetic operator had five operators. That is addition, subtraction, multiplication, division, and modulus. As you know, addition, subtraction, multiplication, and division are the common operators. But here new operator what we are studying is modulus operator. Here the modulus operator is given with a percentage symbol and this will consider the remainder as the answer. Okay, just a brief division of arithmetic operators. We have five operators, that is addition, subtraction, multiplication, division, and modulus. All these four are known to you. The new one is modulus, which will consider remainder as the answer, whereas division will consider quotient as the answer. Is it clear? And the next coming to the relational operator. Relational operators are greater than or equal to, less than or equal to, and here instead of equal to symbol, you have a double equal to symbol here. This is a relational operator. Double equal to is a relational operator where it is comparing two variables. Okay, they are comparing two variables whether they are equal to. Right, 7 is equal to 7 or 2 is equal to 2 and 8 is equal to 2. In this way, we are comparing two variables, okay, or two constant values. This is called as the relational operator. When you are taking a single equal to, it is an assignment operator. Means you are assigning a value to a variable. Okay, here you are assigning a value to a variable. A is equal to 2 means you are assigning a value 2 to a variable A. So this is not the relational operator. It comes under the assignment operator. The relational operator will have a double equal to symbol where you are comparing two values and giving the answer as true or false. Here it is, in this condition it is true. This condition it is true. Whereas 8 is equal to 2. In this condition the answer is false. So comparing the two values, it is not equal to, so it is the answer is false. Another operator we have is exclamation mark, that is not equal to. Okay, this is a exclamation mark. It is known as not equal to. So the relational operators are greater than, less than, greater than or equal to, less than or equal to, double equal to, and not equal to are the relational operators where you are going to compare two variables and give the output either as true or false. Is it clear? This was the operators called as relational and arithmetic operators. Today we will see what is a logical operator. Today we will see what is a logical operator. Here, logical operator combines two variables. Okay, it combines two or more relational operators. Yesterday I told relational operators will compare. Relational operators will compare, whereas logical operators will combine. The difference is compare and combine. Relational operators will compare and logical operators will combine two or more relational operators. Okay, the logical operator will combine two or more relational operators, and there are three types of relational or logical operators. That is logical and logical or, and third one is logical not. Okay, logical operator combines, remember this word, it combines two or more relational operators, and there are three types of logical operators, that is logical and, logical or, and logical not. There are three types of logical operators. Now we will see one by one. So the first one is logical and. Here you have to consider an example of two variables. Okay, now we are taking two inputs. And this is our output for AND operator. This is the table for logical AND. Here I am taking the input as A and B. Okay, we are taking two input and we will be getting an output here. And here, remember that true is given with the value 1 and false is given with the value 0. Okay, when I am telling true, the value for true is 1 and the value of false is 0. Remember this, the value of true is 1 and the value of false is 0. So now I am taking the input for A as 1 and B as 1. That is true and true. And then I am taking one value as true and another value as false. And one value as false and one value as true and the other as false. If you remember data representation, remember data representation, they have taken inputs as 1 and 0. The same way, logical operators work on these binary systems. Okay, so I have taken 1, 1, 0, 0, 1, 0, 1, 0. The AND operator works in this way. Only when both the inputs are true. Okay, only when both the inputs are true, the output will be true. Is it clear? Only when the two inputs are true, the output will be true. In the other cases, either one of the input is false, then the output will be false. Understood? Instead of writing true and false, I am taking the value of 1 and false value of 0. So here, when both the inputs are true, the output is true. Either any one of the input is false, the output will be false. Is it clear? This is the logical AND operator. Understood? This is the logical operator where if you are taking two inputs as true, the output will be true. Either any one of the output is false, then the output will be false. The same thing for logical OR operator. Consider the logical OR operator. The logical OR operator is vice versa to the AND operator. In the OR operator, when both the inputs are false, the output will be false and either any one of the input is true, the output will be true. Is it clear? For the logical OR operator, if both the inputs are false, then the output will be false and either any one of the input is true, then the output will be true. Is it clear? AND operator was reverse to that. You are getting 1, 0, 0, 0. The OR is just opposite to that. The AND operator, if two operators were true, it was true, and whereas the OR operator, if both are false, then the answer will be false. This is your logical OR operator. Is it clear? Today I will do more for logical operators and the other two what I am teaching. You have a clear. Last one is not. Here, the not operator is called as an inverter. Logical is called as an inverter. It means if you are giving a true value, it gives the output as false. If you are giving the input as true, then the output is false. If you are giving the output input as false, the output will be true. It's just the vice versa. Not operator. Inverter. Not operator is called an inverter, where if you are giving a value as true, it will be value as false. If you are giving it as false, it will be value as true. Logical operators are clear. The logical identified words, look at the board. The logical operators are used to combine two or more relational expressions. And here, there are three types of operators, that is AND, OR, and NOT. First one is we have seen AND operator. Here in the AND operator, when all the conditions are true, okay, if both the inputs are true, then the output will be true. I will give an example for this. To show the AND operator, consider the example here. So logical and suppose equal to 8 and it is 3 is equal to 3. Okay, this is the example we are working on logical and. For logical and, the inputs are if both are true, is true. This is the and. See here. Now I have given the example 7 is equal to 8 and this is the and operator. This one. So write an logical and then making use of this symbol that is called as and operator. So the example here is 7 is equal to 8 and 3 is equal to 3. This is an example. So listen here. 7 is equal to 8. Is it true or false? 7 is equal to 8. It is. With an example, you can understand. All of those are texting it is not clear. Listen now, logical and how it is working on relational operator. I said it is combined two or more relational operators. So here we are having relational operator equal to. So we are combining these two with using the logical and operator. So here 7 is equal to 8 is false. So for false the value is 0 and 3 is equal to 3. Here the answer is true. For true, the value is 1. Is it clear? 7 is equal to 8 is false. That is 0. 3 is equal to 1. It is true. So the value is 1. So 0 and 1 means here 0 and 1 means the output is 0. So the answer here is false. Now it is clear. Now is this clear? Okay. This is an example. So same way, you see one more example. 5 is greater than 8 and 3 is equal to 3. Greater than 7. So here I have taken 5 is greater than 8 and 3 is greater than 7. Now according to the AND operator, 5 is greater than 8. It is false. False means I have to take it as 0. And 3 is greater than 7. It is false. So I have to take the answer as 0. So 0 and 0 means the answer for me is false here. So the answer is 0. Now it is clear. The logical and is clear to everyone. I hope everything is clear now for AND operator. The same thing is compared for logical OR. For OR, it is this operator. Two lines. Okay. For OR, we are writing it in this way. The symbol for OR is this one. So here, the same example I am taking. 7 is equal to 8 or 3 equal to 3. The same thing. 10 is equal to 8 is false. Or it is 2, it is 1. So what is the answer in the OR? If both are false, it is false, otherwise it is true. It is the OR table. So 0 and 1, it means the answer is 1. That is true. This is for OR condition. The same thing for another example. 5 is greater than 8 is false. Or 3 is greater than 7 is false. So 0 and 0 will again give you the answer as 0. Now this is clear. Logical and OR is clear. The same way, not example. So logical not. I said not is an inverter. Here, if you are taking 5 is greater than 7. The answer is false, right? According to the condition, the answer is false. But in case you are making use of not operator is given with exclamatory mark. So if you are taking not 5 greater than 7, the actual answer is 0. It is false. But in case if you are making use of logical operator now, then the answer will be 1. Why? Because not operator acts as an inverter, like a switch off and on. The same way, not as an inverter. You get the answer as 0, it will be 1. If you are getting it as 1, the answer will be 0. Now the logical operators are clear. Logical operators are understood? Fine. We'll continue with the next one. So the next operator we will see today is unary operator. Unary operator. Okay. Listen, unary operator. Here the word is unary means single. Unary means single. So these operators act on a single variable. A unary means it is one. So what it is doing? It acts only on a single variable. Here we have two types of unary operators, that is plus plus and minus minus. Okay, we have two types of unary operators, that is plus plus and minus minus. This is called as increment operator. This is called as increment operator, and this is called as decrement operator. Understood? Unary operator acts on a single variable, and there are two types of unary operators. One is increment operator and one is decrement operator. So far, you have seen only single plus and minus. Only plus and minus means arithmetic operator. When you have a double plus operator, it means it is a unary operator. We have a single minus, subtraction, and it is arithmetic operator. When you have two minus symbols, it is a decrement operator. And for example, I show how it works. Suppose it is a plus plus. Okay, it is a plus plus. And assume a is equal to 5. Okay, we are taking a value a is equal to 5, and this is our expression. Okay.
Hello.
What you have next plus. Then here you have two plus operators. One will act as the automatic operator and another will act as a value 1. Okay. You have two plus symbols. Okay. You have two plus symbols. In that, one plus symbol will act as automatic operator. One symbol will act as automatic operator, and another plus symbol will give you the value as 1. Okay, so then it becomes 5 plus 1. Then the answer is 6. Clear? This is the unary operator. Unary operator is acting only on a single variable, and we are giving an increment operator. One operator acts as the automatic operator, and another acts as the value as 1. So 5 plus 1 is equal to 6. Suppose if it is n is equal to x plus plus, then n is equal to, suppose x value is 10. Suppose x value is 10, then 10 plus 1, that is n is equal to 11. Understood increment operator? This is how the increment operator works. The same thing, if you are taking a decrement operator, that is n is equal to a minus minus. Suppose n value is 6. N value is 6. The same way, one minus symbol acts as the automatic operator, and one more minus symbol acts as the value of 1. One minus will act as the automatic operator, and another minus symbol will act as the value of 1. So here, substitute the value. N is equal to a has taken 6. So 6 minus 1. N is equal to 5. Is that clear? N equal to 5. This is how the decrement operator works. Is that clear what I have told? Look at the board. I will tell once again. Unary operators act on a single element. Here you have two types of unary operators, that is increment operator and decrement operator. In the increment operator, we have two plus symbols. We have two plus symbols. One symbol will act as arithmetic operator and one plus symbol will act as the value of 1. The same way the decrement operator will act as arithmetic operator and this acts as the value 1. I've given the examples down. N equal to A minus minus means N is equal to 6 minus 1. I've taken value of A as 6. So the value is 5. Suppose now I have written it as in this manner. You can see the example that I have written in this manner. So this is called as post increment. This is called as post increment. Suppose if the operators are before the variable, if the operators are before the variable, then it is called as pre-increment or decrement. Remember this, if the operators are after the variable, it is called as post-increment. In case if the operators are before the variable, then it is called as pre-increment or decrement. Unary operators are clear? All of you? Unary operators are clear? So today we have seen the logical operators, unary operators, and shall I continue shorthand operators or shall I do it tomorrow? Shall we continue? Shorthand operators, I have to explain 5 operators, I will continue tomorrow. Now I will sending the note to complete it and keep it in front of you tomorrow. I will be explaining the shorthand operators. Okay? Thank you.